Okay, can you see the slides now on the screen? Assalamu alaikum everyone. This is week 5 and 6 of cis1103. This is an advanced chapter on networking. So here we will discuss protocols and addressing on networks, okay? Why do we need network? We need network, why? To communicate between computers or networks and share information, right? Or maybe share resources, okay? And the communication always starts with a message or information that you want to transfer or send from sender to receiver, okay? So all communication methods have 3 elements in common. The source or sender or transmitter, okay? Message source can be like what? People, end user, yani electronic device. The second element is the destination or the receiver. And the third element is how you will send it, through what? So it's the medium. Okay, so we have sender, receiver, and medium. Okay. So before we start communicating with each other, we have to put rules, standards. Like when people want to talk to each other, they need to agree which language they will talk. Who will talk first? When you will stop, when you will listen. We call this protocols. So these rules or protocols must be followed for the message to be successfully delivered and understood. Okay. It should be identified, sender and receiver. It should be agreed by all parties. And speed and timing should be agreed. And confirmation or acknowledgement required should be also discussed. So these are the characteristics of a protocol. Can you please read them? I will go over them, but have a look at it. First of all, the message format. Let's imagine we are talking about the data going inside the cable, the medium. So we have to know what format is the message. Is it electric or is it Wi-Fi signal? Message size, what is the size? Timing and speed, what is the speed of transmitting? Encoding, is the message encoded? Okay. Encapsulation, each message transmitted on a network must include a header that contains addressing information that identifies the source and destination hosts. Okay. Message pattern, some messages require an acknowledgement before the next message can be sent. So these are all characteristics, okay, of a protocol. And they are different from protocol to protocol. Okay? So what is a communication standard? A standard is a set of rules that determines how something or communication must be done. Networking and internet standards ensures that all devices connecting to the network are using the same set of rules or protocols. Okay? Also, it is possible, by the way, for different types of devices to send information to each other over the internet. Why? Because we are all agreed on the protocol or what are the standards. So even if you have like Mac, I have PC, we can still communicate with each other. We have 2 very common standards, very famous and very main standards. OSI, Open System Interconnection Model. Please, you have to know them. And TCP/IP model. The OSI is created by the IOS, International Organization for Standards. OSI Reference Model, it helps network engineers and systems to define how data communication occur on a computer network from one computer to another, regardless of whether the computer is or what software runs. Yani regardless of where is the computer or what is it's running. Okay. The OSI have 7 layers. Each layer communicates to the layer adjacent to it, and its equivalent layer on the, yani the sender has 7 layers, the receiver has 7 layers. Okay, we will see these layers. It was created by the iOS and is represented in the United States by the American National Standards Institute, ANSI. They are responsible for this protocol, this model. This is the OSI model. You have to know these layers. This is layer 1. Physical is layer 1. So we go up, down, up. Data link 2, network 3, transport 4, session 5, 6, presentation, 7, application. Session, presentation, and application, they are upper layers. And those 4 are lower layers. Okay? The session layer can talk to the presentation layer or transport layer. The session layer does not talk to the application layer directly. It's only talks to the layer next to it and to the session layer in the receiver. Understood? Okay. That's why we call it peer-to-peer network. Peer-to-peer يعني مثل بعض. Session talk with session. Here we see this, what I told you now, application layer talks with the application layer here. Okay. So my message application, it talks to the presentation, goes down here, and then when it reaches physical, it will go up again until it reaches application. So application talks with application. The message from application finally will be read by application. Okay. Encapsulation, it is like when you write a letter. When you write a letter, you don't put it in the post office على طول. لا, you put it inside envelope, صح؟ حطها جوا ظرف, envelope. And then on the envelope you write who's the sender, who's the receiver. Okay? Or when you want to send something by email, you have to use a program to include your message inside the email or Outlook, and you have to put sender and receiver. This envelope, we call it encapsulation. So I am putting my data inside a capsule. So it's called encapsulation. Encapsulation, by definition, is taking the data from the previous layer, adding a header to it, or sometime a trailer, and passing it to the next layer where the process is repeated. Again, so data, when it comes to the application will add header. It goes here to the presentation, it will add header. The data link layer adds header and trailer. Don't forget that. So which layer adds header and trailer? Application layer. Layer number 2. The data in each layer, it is given a name, the encapsulation. It is in the application. In the first 3 layers, we call it data. In the transport layer, it is called segment. In the network layer, the encapsulation is called packet. Data link layer, it is called frames. In the physical layer, it's called bits. Understood? You have to know these names. De-encapsulation, when the data arrives on the receiver, the opposite is happening. So de-encapsulation is the opposite of encapsulation. Okay. So the headers and the trailers are there for a purpose. They contain key information that allows the data to be processed. Like I told you, when you write on the envelope, who's the sender, who's the receiver, you put a stamp, or is it express, or okay. You have any questions so far? Okay. So let's start by the application layer. Layer number 7. It is providing the interface between the application, okay, and the user use the application like Word. So it provides the interface between the application and the underlying network over which messages are transmitted. Some examples of these application layer protocols are SMTP, POP, IMAP, HTTP, and FTP. Okay. Note, applications don't reside on the application layer of the OSI model. In reality, they sit above the OSI model. So here we have users. She is browsing, or he is browsing. So he's using the application layer. Browsing using what? Which application, do you know? Which protocol? Which application? HTTP. Okay. Presentation layer. It has three primary functions: formatting, or presenting data at the source device into a compatible format for receipt by destination device. That's the function of the presentation layer. Also, it does compression and decompression. Also, it does encryption. Very important layer. Okay. You see here, it is converted from text into binary. Then the binary is encrypted. Session layer. It creates and maintains dialogues between source and destination applications. It handles the exchange of information to initiate dialogues. It keeps them active and to restart a session that are disrupted or idle for a long period of time. All done by the session layer. You have to know these functions. Have you studied this before? I know some students, they take Cisco courses and then they have some idea. Anybody here learned this in your previous studies? Nobody? Okay. It's okay. Transport layer. The transport layer is responsible for the delivery of a message from one process to another. Surely process is application or message program running on a host. The two main protocols for transport are TCP and UDP, and there are differences between them. TCP stands for Transmission Control Protocol, UDP, User Datagram Protocol. If a message is too large, TCP device divides it into smaller messages called segments. Okay, segments. All right. So here we have a TCP segment. What it contains in the header of TCP segment, it contains source process number, lower port number, and destination port number. Okay. Also, there are many applications or process running on each host on the network. Yani, let me tell you something. Transport layer. Let's say I have Microsoft. I am here using my email, and I am sending message. Transport layer will open a port, like door, on your computer, on your network. That, oh, okay, he's using this application. This is the port for this application. When you receive the data for this, the response, it will go to the same port. Okay, so this is the purpose of transport. Okay, that's why you can use multiple programs. You can use browser, you can send email, you can type Word, because every one of them is using different port. They don't mix with each other. Okay. So to pass data streams to the proper application, the transport layer must identify the target. To accomplish this, the transport layer assigns each application an identifier. This identifier is called a port. Tamam? Okay. And there are some very common ports. Yani for HTTP, it is port 80. We know that. Okay. So process to process delivery, email will talk directly with email. and they use specific port. Same thing, your application VoIP talking to VoIP machine. All right? Network layer. Network layer is responsible for the delivery of individual packets from the source host to the destination host. Okay? And network layer uses something called logical addressing or IP address. You know the IP address, 192.168.0.1. So this is responsibility of network layer. So the header of the network layer will have source IP address and destination IP address. How is the data delivered from one network to another network or to the internet? By routing. So it will select the message from here. Who decides it's going like this? Or it will go this side? Who will decide? The routing. Routing. يعني الراوتر. Routing protocol. How the routers will route. Route يعني كيف راح يوجهوا الرسالة. How they will forward it. Okay. So routing is selecting the best path to transmit packet from source to destination by definition. Okay. So what is an IP address? I just gave you an example. It is a unique address that identifies a device on the internet or a local network. Okay. IP stands for Internet Protocol, which is a set of rules governing the format of data sent over the network or internet. We have to know now some terms. You know bit, what is bit? Either 0 or 1. صح؟ أصغر وحدة, the smallest unit in binary. We have byte. Byte is how many bits? 8. Okay. Here they say byte is 7 or 8. Okay. So for the rest of this chapter, it is 8 bits. Okay. What is octet? It is made of 8 bits. So it is an 8-bit binary number. Okay. IP address is 32 bits. IP version 4, by the way. This is IP version 4. Okay, don't forget that. And these divided into 4 octets. We'll give you example here. 172.16.30.56. Each one of these section is called octet, which is عبارة عن, it is 8 bits. So if I want to convert, let's say convert 16 into binary. What is binary in 16 in binary? It is 0, 0, 0, 0, 1. How did I know that? Because the first bit is 0, 1, 2, 4, 8, 16. We will show you some examples, okay? But you need to know that. How to do binary, how to read the binary number. We will do a lab. Here, you have an exercise. By the way, because I have 8 bits in the octet, the higher number I can get with octet is 255. Yani if these all are ones, it is 255. So I want to ask you a question. What is, if this one is 0, what will be the number? 254. 54. Very good. So if this was 0, 0, yellow. 250, 52, 2. ليش? Because this one is equal to 1. This one is actually equivalent to 2. So this one is equivalent to what? 4. See how it jump? 1, 2, 4, 18, 16. Okay? Yeah. But can I have a number like this? It's invalid. Why? Because it is above 255. صح? You cannot have an IP address of 255, 3 above 255. ما في. Not allowed. Okay. Why this one is invalid? Because also it is above 255. I cannot get this number. And if I have, like if I tell you, if you have 3 digits, can you make them 1 million? No, because 3 digits, maximum 999. Same thing, I have 8 bits, maximum is 255. So if I see this number, oh, there's something wrong, not correct. All right? Any questions? Okay. Okay, source to destination delivery. Here, please pay attention to this example. The message is, let's say that this laptop wants to send a message from A to F. A to F. The message will come from A. It will have the source IP address, شو IP address تبع computer laptop اللي هو this one. And what is the destination IP address? 10.10.1.1. Okay. So it will come to the router. The router check the destination. Oh, the destination, it has to go this way, according to the routing table. So it will send it to router E, and router E again will send it directly to router F. We call this source to destination delivery. But what about if laptop wants to send information to laptop D, to computer D? It will go through which router? C. Sorry. You see here, when the message is traveling, it has the source IP address. The source IP address 192.168.1.1 اللي هو هذا. The destination is this one. You see it here? It's not changed. Source and destination IP address is not changed during the travel. Now we come to the data link layer, which is layer number 2. It is responsible for moving frames from one hub to the next. And it uses something called physical addressing. The header of the data link layer includes the source and destination MAC address. Physical address اللي هو MAC address اللي هو your network card address. This card, you know the network card? Where you put your network cable? This is the network card. It has each network card, they have their unique MAC address. Each network card. We call this physical address. It's not IP address, this is a physical address. Okay? Physical address is used by the data link layer. Network address or IP address is used by which layer? Network layer and the router. Okay? I suggest you write notes while I'm talking if you like, or you can watch the recording. Okay, so data link layer frame. In the frame, you will have here source MAC address and destination MAC address. In the packet, what did we have? Who remembers? Source IP address and destination IP address. In the data link layer, source MAC address and destination MAC address. Tamam? And also, data link layer adds a trailer. Don't forget that. It adds header and trailer. So what is that MAC address? It is data link layer or media access control address. It is 48 bits. The IP address, how many bits? 32. Very good. And the 48 bits are written in 6 hex numbers, separated by colons. We call it physical address, MAC address. Okay? Even some people call it hardware address. Physical or MAC address is good. Okay? Are embedded on each NIC card. NIC اللي هي network interface card, like this one. We call it NIC card. The traditional MAC address contains 2 parts. Remember, we said it is 48 bits or 6 hex. Hex number, yani each number is equal to 4 bits. So if I have 6 times 4, sorry, sorry, 48 bits. Each hex is equal to 8 bits. 8 bits. 8 bits. So if I have 6 hex numbers, 6 times 8, 48. Okay. The first 24 bits are known as OUI, يعني Organizationally Unique Identifier, اللي هو manufacturer ID. يعني هاي الشركة, this company that's manufactured these cards, the first 24 bits will have their ID, the company ID. The last 24 bits make up the extension identifier or device ID. Okay? And manufacturer, الشركة المصنعة, assign each NIC a unique device ID by law. All right? By the way, MAC address is used by the switch. IP address is used by the router. Please note, remember this. So what does data link layer do? It forwards frame. So frames are sent on a LAN. They are coming from a MAC address and sent to another MAC address. If a network adapter is receiving a frame, it is comparing the frame destination to the adapter's own MAC address. If the address match, the frame is processed. Otherwise, it's discarded. Okay, let's see this example. Computer C sends a message to computer B. Okay? I need you to pay attention, please. Sorry, computer C, yeah, to computer B. This is the destination B. What will happen? The message will come here. When it arrives to the server will check the destination MAC address. Is it same like mine? Is it same? So it will discard. Here the message is coming here also. It will check. Is it matching? Is it for me? Yes. So it will read it. خلاص? Very good. What type of network is this? This is called LAN. Okay, small network. LAN, local area network. This is the hub-to-hub delivery in the network or in the internet. We gave you this example before. So A is sending the message to B. If it's going to up, it will go from hub to hub. يعني it will jump from router to router. Okay? يعني زي أنت بدك تسافر مثلا على بلد very far country. You have to go to some hubs, صح? Or airports. Yeah, transition. Yeah, transition. So here it's coming from A to B. This is called one hub. Each time you hit a router, it's called a hub. So here one hub, second hub, okay? And then it arrives to the destination. So how many hubs here? We have 1, 2, 3. Tamam? Last but not least, the physical layer is where the physical layer is the cable that sends the data, or maybe the Wi-Fi. Is responsible for sending bits via a wired or wireless transmission. Bits can be transmitted as wavelength يعني signal, like radio signal. Voltage, اللي هو الكهرباء, electricity in the cable. Or light. In which cable? Which cable uses light? Fiber optic. Very good. Now very popular. Okay, so here we have sample electrical signal transmitted on copper cable. We have a representative light pulse. This is a fiber signal. And then here we have a wireless signal, microwave. Okay. As you can see here, in the wireless signal, this is my digital signal. This is 0, 1, 0. You see, when it is 0, the signal is low. When it is 1, the signal is high. 1 high, 1 high, 0 low. And we have different type of modulation. We have amplitude modulation, يعني when it is 0, amplitude يعني القيمة، قيمة السيجنال, it is low. When it is 1, you see it is high. You see the mountain here, the top, the peak, it is high. That's why it's called amplitude modulation. يعني الامplitude أو الpeak value القمة or the top value is according to the bit. If it is 0, it is low. If it is 1, it is high. The other method is called frequency modulation. Here, the frequency or the speed. The frequency, if it is 0, it is low frequency. If there is 1, it is high frequency. 0, low. High, 1, high. Okay. Last one is phase modulation. Phase here, the angle. When it is 0, it is going this direction. If it is 1, it is going another direction. Understood? The angle is changing according if it is 0, or the phase is changing if it is 0 or 1. So AM, the amplitude modulation, FM is frequency modulation, PM is phase modulation. You need to know these three. Okay. So this is an important diagram. This is how layers work together. Okay. First, the application started. The data is sent to the presentation layer, session layer, transport, network, data link, and physical. When it arrives at the destination, okay, it goes from the physical to the data link and so on. All right. At the switch, which two layers are checked in the switch? We said switch is active in which layer? Layer 2, data link layer. So the switch, in the switch, it is only going layer 1, then layer 2 only. Then the switch will send the data. When it arrives at the router, we said the router deals with IP address, and this is active on network layer, yani layer 3. So at the router, it will go up to layer 3. And then the router will send it to the computer. In the computer, it will go again to the 7th layer. Okay, very important diagram. And these are the names. In the switch or data link layer, it is called frame. In the router, it is called what? Router, packet. Okay, in the application layer, it's called data. That's it for this chapter. Now let me show you, please, again. I think you maybe it's worth it to mention this slide again here. The name of encapsulation in each layer. Please remember that always. Okay. Here. In data link, second layer, it is called frame. In physical, it is bits. Network layer, it is packet. In transport, it is segment. All right? Any questions? Yeah. You start from down here. In the physical layer, it is bits. When it reaches the second layer, it is called frame. In the network layer, it is packet. In the transport layer, it is called segment. Session, presentation, and application, they are all called data. All right? Okay. Any other questions? Okay, let me